all need to just like hope the demo guides. I mean, this is just going to be ridiculous. So if this doesn't work, man, we're just in this together. I didn't fail. We failed together. So this is not just me. I'm doing this for the sake of you guys here. So I'm going to just tear down my cluster that is working, so that way we just go through it from scratch. And it's going to really destroy my confidence levels, because when you have a working cluster, you just want to use it, right? And I'm just going to like throw that away just for you guys. So we're in this together, right?
Yes.
All right. I'm going to watch Twitter, because you guys are like, dude is an idiot. Like, he had it working, and he turned it off. So fail. So let's not do that to me.
You have a long QuickTime video instead?
Yeah. Oh, I go to the editor and say, I cut that whole section out. It didn't happen. All right, so let's get GCE up here. And I promise to go through all of this in a way that you would actually do it yourselves. Because when I build these workshops, I do it in a way where I can copy and paste all of these things and it just works. And if it fails, I'll fix it here. So I have an existing cluster. I'm going to kill it so we can go through all the steps to make sure that we're doing this correctly. So here's what everything looks like right now. I kind of have 3-node etcd cluster. I have a Kubernetes API, and I have 3 workers here. So what I'm going to do in Terraform, I'm going to say Terraform tear down that cluster. And we'll see if Terraform is going to behave for us. So what we can do with Terraform, so what Terraform is, think cloud formation that works on multiple cloud providers, right? And we're going to look at what this thing looks like. But the idea and goals of Terraform is to give us a way to like specify the entire infrastructure and be able to increment on it. So if I'm starting with 3 nodes, I can add like 2 more, and it only does the delta. That's an ambitious goal, and it works in most cases. So I can do things like Terraform plan, like, is there anything to do? And right now it's like, nah, that cluster that you specified works. There's nothing to do. If I do change some variable, I'm just going to show you guys this so we can kind of drive the point home a little bit. Right now I said I wanted 3 workers, and I said I want 4. I can say Terraform, based on that and the state that you know about, is there anything to do? And it's like, hey, there's a diff here. You're missing a node. You're missing node 3, right? And I say, all right, that looks good as part of the plan here. And I want you to do is go ahead and apply that. So we're missing a node. I want you to go and adjust my infrastructure to be what I said it should be. And if everything works, and sometimes I've seen like Google straight run out of like instances in a zone. And that's like seriously sad. So what happens here is an API call is being made to adjust this thing. And what we should see is another worker node fire up in the cluster. So 0 index, and we'll be looking for node number 3. So it's doing its thing. Not sure what it's doing. It'd be helpful if it told me. So it's calculating all the templates I have to make sure it connects to the right etcd cluster, and all the things it needs to do to make sure that we're going to talk to the right API server, the whole 9. And let's refresh here. Things need to start working because we're only getting started. We have a bunch to do. Come on. So it's trying to create instance number 3 in that same zone. And I've seen this fail before when it's like, look, we just don't have any more compute capacity there. And it might be some of you guys like spinning up and hogging all of this stuff. But I did this in a class with 30 people, and like, I don't know, it just ran out halfway, and we had to go to another zone to finish up. All right, there it is. So it's spinning up now. And that's the whole process, right, of like grabbing the image, booting from the image, and there's a bunch of orchestration stuff that happens. And we'll take a peek at that orchestration that happens. So it's going in now, and what it's doing is making sure that this instance actually comes up by following the operation ID that it got back. And when it comes back, it's going to be healthy. Come on.
But you could have workers across zones, right?
Yes, totally can have workers across zones. You have to be in the same data center. But with the overlay networking stuff, like by default, and like Flannel and Weave and all this, it does allow you to go over WANs like that. But man, it's probably going to be incredibly slow, some of the latency there. I mean, I've just seen SSL just stop working because of the timeouts on the handshakes. So you got to be careful with that kind of stuff. All right, so that node came up. It added a new node. And this just, I configured Terraform to tell me what the API is of my cluster so I can start interacting with it. But we're going to tear this whole thing down. So that'll, well, let's let this finish 100%. GCE is probably waiting until it can actually log in and pass the ping. So we'll let it come up. Well, forget it. I'm going to destroy it so we can go through the other steps. So what I want to do now is say, all right, Terraform, I don't want any of that cluster anymore. So I should be able to say Terraform destroy. And it's going to go away. Do you really want to destroy this? Imagine doing that in production. That's like the thing that's like really dangerous. Like, yeah, do it. And then you just like resign, update LinkedIn. Right, so this stuff will get destroyed. So what we're doing here is we're doing two things. To set this up, we need to install a bunch of stuff. So the bunch of stuff that I wanted to install, I'm just using Packer forward. And what Packer does is like, look, here's some credentials that come from external files, so you can't see my secrets. No free Bitcoin mining for you guys. I give it a couple builders, and I want to build this image on GCE, and I'm just giving it a disk size and certain other things. And then I have a provisioner. So all I'm doing here is, by default, I'm bringing in all the binaries from Kubernetes. There's like 6 binaries. What I do is I take the official binaries and I put them in this thing. We also have some Rocket containers and some Docker containers for deploying all of this. And we'll have some documentation on our site on how you do it the CoreOS way with like Cloud Init and some other tricks. But a lot of times I choose to just run them as static binaries under opt. So what I'm doing here is like I'm going to prepare an image. I'm going to put all of the Kubernetes binaries under opt. And once they're under opt, I just chmod them to make sure that they're executable. And then I put all of the unit files in place, right? Now here's something I've been doing different, kind of a thing that I got from like the Red Hat community about how they build service files. And you notice here what I'm doing is I have very little flags inside of my unit file now. I'm starting to put everything in an environment file, even things like the options for like Docker. Same thing for like the kubelet. Let's look at the unit for, let's see, the API server here. So the API server is just a static Go binary, and I give it a bunch of API server options here. And we're going to do all of that inside of Terraform because I'm going to need things like the etcd server will come from the provisioned etcd nodes. I don't know them ahead of time. So I'll have a template that gets filled out. But when you think about it, the whole Kubernetes setup is a collection of these components. I actually bring in Docker from scratch just to make sure I have the right version of Docker for the cluster that I'm running. I'm doing a dedicated etcd service. I have Flannel for the overlay network. There's ways you can do this without Flannel, and I do that in different tutorials. The API server, the controller manager, the kubelet itself, the proxy server, and the scheduler. That's the entire Kubernetes stack all the way down to Docker. If you have a Linux kernel, and since all these are statically linked Go binaries, they should just run on any modern Linux kernel. You gotta be careful with backends and Docker. So once we have that, so now I'm destroying all of my stuff. So all these should go away here periodically. And we're just start from scratch. We are going to take a peek at, so what I would do here is I would just say Packer build, and I will get that Packer image. And what I'm doing with my image, I'm storing that. All right, so my infrastructure is gone. So what I did, I used Packer to build this kubestack image. Just gave it a name. It's running Kubernetes 0.17, and I gave it a date. So I'm going to use this image in my Terraform setup. And really quick, just to show you guys all the components, and there's a bit of orchestration needed to make all of this work. I never want to give people the illusion that Kubernetes is like an easy thing when you start talking about the security components and the certs and the keys and all these things. So you got to do a little bit of things there. So I think most of these things will have some type of documentation where it'll tell you, here's the level of security you want, here's all the stuff you're going to have to configure. If you just want a wide open cluster, you have to configure a little bit less. What we're going to do is we are going to set up some tokens to give access, and Kubernetes will generate SSL certs by default. So when you boot it by default and it doesn't detect any certs, it will generate some temporary ones on its own. And unless we go and grab the CA from that, we're going to have to just do insecure verification on that endpoint. So in Terraform, we're going to use is this Terraform definition, kubestack TF. It's a lot going on here, but not too bad. So at the very top here, I'm saying I want my output to be the IP address of the API server, because it's the only thing I'm going to interact with the whole entire cluster. Here's a template file so I can actually capture all of those IPs or the discovery tokens and things I need for setting up etcd. Right? So this is going to drop that environment file in place that will be used by the systemd unit file. Here's a big template that will be used by all the Kubernetes components. So I'm just making one big shared environment file. And you can do a little fancy thing in here with Terraform where you say, look, all the etcd servers that you spin up, collect them into an array for me. And what I'm using is the default GCE format for DNS. to append them, right? So I know by default, actually I get the full name from here, right? And I know what the API server is going to be as well, right? It's going to append the cluster name, and then this is just going to be the default layout that you get for GCE. And all these Flannel backends and network, these are all the settings I would normally do when I'm spinning up a cluster or doing it through a cloud config. And we come down here and we're setting up our Google credentials, or we could do this in a different cloud provider, Amazon. It should work. You're going to have to tweak these bits. First, I'm setting up the Kubernetes API firewall entry. So once I have my firewall Kubernetes API server up, I'm enabling the secure port to be exposed. And then I'm saying I want 3 etcd servers with these machine types, and it can do some forwarding because this is how the network model works in Kubernetes. You need to be able to forward because the IPs that we're going to be using aren't bound to interfaces, and GCE knows nothing about them. So we're going to need to make sure that these machines are comfortable forwarding to the remote destinations and let Flannel, or you can let the router handle all of those things. So that's an important thing you're going to need inside of a Kubernetes cluster. And a disk image. So we do 3 of those for etcd. We make sure our SSH keys are there. And then Kubernetes has this nice thing about provisioning. So once I'm up and running with those machines, it's going to go through and provision them. So right now I'm just like firming up the environment files to make sure etcd has all of its configuration information and so forth. Then I'm starting etcd, right? So systemd, start etcd, is up and running, and that's the SSH connection. And then we repeat the same thing for all the other components. And the other components will all live on separate servers. So the API server, I'm only going to just run one of those. And we do the same thing. We go through, we set it all up. We do a little bit of orchestration to make sure it has the right environment variables. And on all of the servers, they're going to have Flannels. They're going to be a part of the overlay network, so they can communicate on the fabric. We're going to enable Docker, the API server, the controller, and all of these unit files express their dependencies on each other. So that way we can start them in any order. It should work fine. And that's the API server. And then the workers, we basically allow people to give us a custom worker count.
What if you have a private Docker, private repository for the Docker images?
Oh, that's fine, as long as you can reach them. Now, so the login, right? So you need the whole Docker login. So there's a couple ways to do it. In Kubernetes now, and I think slightly later versions, there's this idea of secrets. And I think they've done something special case for like the Docker secrets. So what will happen is we can transfer all the secrets we need to the kubelet when it comes up, right? And the kubelet can have all those information. Some people choose to do it statically, where you have like kind of all the things that you need, and you put it in the file in the right place, and the kubelet knows to use it and puts it in the right place in the context of making Docker commands. The idea there is that we're going to put this as a first-class thing in the API server. So in the API server, you say, here's all my secrets for Docker or the container runtime that I need. And it will distribute those out to the kubelets as it sees fit. Because it has to take into account namespacing. You may want some things in certain namespace not to have secrets for talking to certain remote repositories. So a lot of that is handled. There's a lot of docs on how to do it manually. It's like, put this here, it's going to work. You can put some objects in the API server, and it can push some things down. But it's really a weird state because no one really knows like how all the registries want to be supported. The basis work, I think, is like the basic auth stuff. I think that works. So there's a lot of discussion on that, but there are solutions for it. And we have time, we'll just point you to some of those docs. So right now I'm just using public images right now, but that's a good question. That's been debated hotly for like 3 months to make sure we have a solution there. And there are docs on how to do that correctly, either using the API objects or putting things in the right place when you provision your node. And this is why I think long-term you're going to need some type of management for these moving files. What happens when the credentials change? You're going to change those on the nodes. So this is why I don't think Cloud Init up once or Vagrant up once is going to help you 6 months from now when you want to go change secrets on select boxes. You're going to need something a little bit more granular than that. You're going to have to actually manage the cluster a little bit. And the goal is to put as much of that in as we can inside of the Kubernetes API and have tooling that can like sync things that are like common to the cluster. But you guys got to think about those things.
And I think just to note, I think HashiCorp's doing that with Vault. That's the new.
Exactly. I was actually talking to some of the Google guys, like maybe having Vault available inside to add another dimension of like, sharing secrets that are encrypted. But nothing's stopping you from doing that right now, actually. You can actually just build some of your tooling to do this. But good point. All right, so here's all the commands. So if you look at these Terraform scripts, it's everything you need to like download and install a complete Kubernetes setup. And all I'm doing with Terraform is like allowing me to avoid using CloudFormation and running a bunch of GCE commands, right? So you can actually build one of these for Amazon, GCE, DigitalOcean. I think they support a bunch of providers and get these up pretty quickly. We do have instructions for how to do this, like with just Cloud Init. If that's the role you want to roll, and you just have your own infrastructure set up, you can do that. But I'm just doing it this way to make it easy to bring up in this case with a single command. So hopefully all those bits are gone. So what I'm going to do here is we're going to follow through the tutorial and see what steps we have to take. Just want to make sure that we have all the objects that this thing's going to create are now deleted.
Did worker matter there? Like the etcd, then API server, and then the worker nodes?
So Terraform takes care of that because I'm expressing dependencies that the API server needs the etcd, and it just spins up those nodes first, and everything else will be spun up in parallel because they have no dependencies. Kind of like Puppet does with this resource graph. All right, so this thing is pretty clean. There's no conflicting rules. All right, so we're going to spin up the cluster. All right, so at this point, we're going to do Terraform plan, and it should tell us that we need everything, right? We need the entire cluster built for us. I'm going to adjust the number of nodes that we want from 3 to 5. So Terraform, tvars. So here's the things that I need. I need my account file, and in the tutorial, we walk through that. I'm configuring flannel here. I want VXLAN, a little more performance on the overlay. Here's the flannel network I want to use. Here's the image I want to use that's in my store, pre-configured with the Kubernetes binaries. The portal net is that VIP pool that you would get when you create services, and we'll see that. So you say up ahead of time, Kubernetes, I want you to allocate from that pool when people ask for services. And that's the thing that you're going to make routable to the different machines. The region that I want to spin things in, the tokens file is what I'm going to give to the API server to say anything in here is going to be like username and token. Now, the plan is that the authentication system will be pluggable. So GCE will probably plug into theirs. Amazon, you could probably plug in there. But if you're in your own environment, you might want to plug into LDAP or Active Directory or something like that. And if you have some OAuth stuff, you can hook into the token system. You can do basic auth. It'll be completely pluggable how you identify people, workers, or clients or consumers of the API. I'm just using a static token system where I'm just giving tokens, and that token will have a username that can just pretty much do everything. But we're going to set up this token to make sure that when we open up our API, it will have HTTPS, but you have to have a token to make requests. You can go more granular and have policies to say that this user can do these things with the API. But we don't have enough time to cover that in much detail. The work account, instead of 4, I'm going to make it 5 here. Or actually, I'll just leave it 4, and we already saw the delta, so I'll just make it 5. Right? This is basic GCE stuff of the zone. We added this cluster name so that we can have multiple Kubernetes clusters. A lot of people have visions that they're going to have this big cluster. You're not. 100,000 nodes in a single cluster is crazy, mainly from just having that big of a failure domain. If you do have that many machines, you probably want to have like 10,000 node clusters, right? So you can do a little bit of cluster design here when you're thinking about rolling into production. One big cluster is just not what you want to do. If you have 500 machines, still partition that thing into failure domains. You don't want to have the whole cluster break and go down. You can normalize things at the networking layer when you start doing load balancing, but just having huge clusters, that's a dangerous spot to be in.
Is there service discovery between clusters, or will that fall apart at that point?
Well, so you can do some things with like DNS with some proxies. So if you're doing like a multi-data center design, you got to figure that out, right? It's like you're going to have edge endpoints that will have like an exposed DNS name, and then you may round robin that at the higher level. So you are going to have to jot down and design and think through this, right? I think a lot of us have been trained that, look, I have 100 machines, going to put them around one ELB, my life is good. And you can do that for small scale, but when you start thinking about these clusters and these schedulers, you're going to have to design, and you may partition workloads based on certain things that they do, and expose higher level endpoints like DNS names that don't really articulate all the things behind it. You just got to draw it out a little bit. All right, and there's a discovery URL. I always make the mistake of not actually renewing this thing. So this is like the biggest pain point, right? Like standing up etcd cluster and you reuse a token. And it works, but it doesn't because you can't talk to it when you're done. So try not to make that mistake. All right, so what we're going to do now is go through the tutorial really quick. So on the tutorial, we want to provision a cluster with Terraform. So a couple of things we have to do. So this talks about a walkthrough through all the environment files and components. And we click through here. The first thing we need to do is grab a discovery token. So we're going to expect 3 nodes in this particular setup. So we're going to generate a token that waits for 3 nodes. How many people know what that size equal 3 does? All right, so when you say size equals 3, as etcd is coming up, and it will wait until the all 3 nodes show up before it starts trying to make progress. And this is done in an attempt to save you from like a partial cluster being bootstrapped. Right? So you come up with one node, it'll just sit there waiting for the other 2 peers to show. Because you could get in a weird state where you're spinning up 3 so you can have room for a little bit of disaster. And if this thing just joined up because it had a quorum with 2, and it started working, and that other node died, that's it, you lost quorum. So during the bootstrap process, it's trying to be safe and say, look, you said 3, we're going to wait for 3 to show up. The other thing that 3 does, if we have 100 nodes, so etcd, the new version, support proxy mode. So if you do this race to go to this discovery token, and the first 3 win and become active members of the cluster. My mic? What happened to the mic? It's off? Batteries? Okay, I'll just speak louder. Okay. So what will happen is, if you lose the race, you're just not in the top 3, you fall back to proxy mode, right? Automatically. And in proxy mode, you read the 3 nodes information to be the cluster that you actually proxy for, right? So that's what 3 means there, right? And etcd just kind of honors that contract to make sure that it doesn't start forming the cluster and start making progress before those nodes actually show up. So we have a new token. The project I'm using is kubestack, and I need my SSH key here so that way I can log in, or you want to switch it up? All right, so we have SSH here. So this is how Terraform does all of its work. Once the machines come up, it's going to put this key in place. And I added my SSH agent to have the private part so it can just automate provisioning the machine over SSH. This is why we need this bit, and it also doubles as the key that I can use to log in later. I'm not using cloud in it at all here. I'm just spinning up the machines and configure them live. There's just other ways of doing it. I find for like the complex orchestration, this helps. We'll do Terraform apply. Let's do plan. We need everything. We'll hit apply. And it should start spinning up the cluster. Take your time. So these are the nodes that are starting to come up here. The etcd machines were being done in parallel because they don't depend on each other. They all come up independently, and they all do this race for that token. If everything works with that token, they'll form a cluster. Once those machines boot fully, and we have an IP address for them, the API server is allowed to form because we need the IP addresses from all 3 in order to configure the API server. Once the API server comes up, everything else will happen asynchronous to spin up the other nodes. We should end up with 5 nodes. So here's going through all the provisioning steps for etcd. So it's adding all of the host information so that it can report back up to the discovery service about the host that it has. We're throwing in all of the assemblies we need to start those services. So you saw a little bit of output from systemd. And now that that's done, we're starting the API server, right? And we can continue to make progress. We can look at the console over here, and we should see that it'll be done soon. And at the end of this process, it's going to spit out the API endpoint. And once it does that, we're going to configure the kubectl command line tool. Now, kubectl is designed to manage multiple clusters. So what we're going to do is form a context to say, hey, this cluster endpoint has this URL, it has this user and this token, or you create them separately. And then we form a context where we say, I want to mix and match, like this user plus this cluster equals this context. Once you set all those up for all the clusters that you want to work with, you just pick a context, and that way you don't have to type out the long server equals this long URL, username equals this, password equals this. You just use the context. And if you're in the right context, you'll be hitting the right cluster with the right credentials. So we'll wait for this to finish, and I'll show you what the secrets file looks like. It's basically a comma-separated set of values. So there's a token, it could be a random string. Ideally, this will come from a server that hands out tokens, and they'll be timed or temporary. And then my username. I'm going to use that when I set up the context. So we'll let this finish provisioning, and we're almost done here. So we're doing the workers in parallel, and you see intermix output from 4 and 1 and 2. And these should be almost done here. It takes the UI a little bit longer to refresh. And then that will be it. That will be the Kubernetes cluster. Now, if I wanted to grow the number of workers, I will go update that variable to 10, run Terraform plan, apply, and I get 10. So it's a little bit elastic. If I want to remove one, it also works. Terraform will destroy a node from the cluster. All right? And what I'm going to do now is, normally I would just have these auto-register themselves, but we're going to register them manually, so we're going to start using the API and the command line tool. We're going to add nodes to the cluster one by one so we can get a feel for it. So this is done now. So now I have this IP address and this port. This is a working cluster protected by SSL, but you need a token to talk to it. So now we need to configure our command line tool to be able to point to this thing. And that's also in the tutorial. I'm just going to walk through the tutorial so that we're doing things the way you would have to do it. Man, I so just like, all right, we're done with that. I'll use the command line tools going forward. So once we have all that done, we're going to configure our command line tool. So we get this output here, and this will be unique to your environment, whatever IP you get. Now we need to configure the kubectl. So this is a command line tool that can express all the API actions that you could possibly do. So instead of making these calls with curl, you can do it with kubectl. But you're free to roll your own client. There's libraries for some languages I think are starting to show up. So what I'm going to do is I'm going to call this cluster kubestack. So I'm going to kubectl config. I'm going to set the cluster name to kubestack. And I'm going to say, you know what, I'm going to do insecure verify. Now what I could do is log into the API server and grab the CA that it generated for itself and use that CA to verify the endpoint. I'm just going to be lazy here. And then I'm going to use the server IP. So we're going to just copy and paste this command. And the server, I don't know, my hotkeys are working. It's not a good day. So I'll just grab this whole thing. So we've now created a new cluster. Now we need to create a user, right? So the user, you have your username. I don't remember the username, so I'm going to look at my secrets. Don't check your secrets into GitHub. If you're into that sort of thing, that's not cool, ever. Someone asked me that the other day, can we just check those secrets in GitHub? It's like, no. I was a little sad about it. Like, you don't get to do that, man. All right, so now that we've set some credentials so that users decouple from the cluster. It can probably be used on multiple clusters. So now what we're going to do is set the context of a user plus cluster combination. So now the user we want to have is for Kelsey Hightower. All right, so now that we have that, we can say we want to use that context, right? So that's the context we're going to be using. And now we can actually do, I'm going to copy and paste to make sure these instructions are legit. All right, so here's all the different clusters that I'm managing, right? So they have all different, there's a cluster called DO. That's the one that's running in DigitalOcean. I have one called blah, 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 kubestack. And I have one local that I run in VMware on my local Mac. All right, let me just clear this out before. Oh, that's really nice. So one of them I'm using client certs here. You see that? So the one that I actually use for real, I'm using client certs. And the kubectl, if you put your certs in a certain place, actually they get stored into the whole system, but they get redacted so people can't see them in your demos, like this, right? So you guys can have fun with this. So if you're watching this video, you can have fun with this for about 0 seconds because that cluster will not exist anymore. So good luck trying that. All right, so now that we have that context, we should be able to start using the command line tool. So we can do like get nodes. So now we're talking to the upstream cluster here. We can do things like cluster info. So it's like, hey, there's a cluster there. And there's more data that you can get from that. But one thing I want to show you is that by default, you get a couple of services. All right, so by default, we get a couple of services. And this is for the Kubernetes API endpoints itself. So remember, someone asked a question is, if I wanted to do my own load balancing from my application, I want to make my own queries to the API server. What you can do is, there's this convention. And I'll show you a little Go app really quick to show you how you reference these things. So if you look at this name here, there's this Kubernetes and there's this Kubernetes read-only service. And if you want to address those VIPs that don't ever change and they're available cluster-wide, no matter where you are, if you hit those IPs, you're going to end up at those endpoints. But if you want to reference them, we can look at a little bit of source code to show you how that works. So pgview, my name, what's my name? All right, there we go, pgview. And then we'll just look at this main.go thing. You can ignore most of this code. And what we want to do is just look at where we start, where we actually connect to Postgres. All right, so here, in one tutorial where we create a Postgres pod and service, you end up where the convention will be the name of the service, service host, service port, right? And with those two pieces of information, you can use that to connect to your endpoints, right? So if you wanted to talk to the API server and you're a freshly deployed pod, one way you could do it is just automatically in your code, just know that I want to talk to the Kubernetes _ service host _ service port, and those will always have the IP and port of the VIP that was created. Since the VIP never moves or changes, you can rely on that for the life cycle of the whole cluster, right, unless someone deletes it. So this is different from saying, well, I'm going to have environment variables that are exactly for the pod or the API server at the particular time. If you do that and the pod moves, that is no longer valid. You got to restart the app to get that repopulated. So what we're doing here is we're saying Kubernetes will inject this at runtime in the pod. So we talked about execution environment on the kubelet. When you launch a pod, it's going to inject a bunch of environment variables so you can have some contract with the cluster. So by default, we get some environment services for the API server. All right, so with that in place, let's start deploying some things. Where was I? All right, good. All right, so now let's start. Let's going to make a pod. So now we have our cluster working. We're going to add some nodes. So one thing is, if I start to schedule anything right now, then it's going to happen because we have no workers in the cluster. So I'm free to submit pods and create replication controllers. Nothing's going to happen because there's no one to make a scheduling decision. And if we were to monitor the logs, it's going to be sitting there pending. There's just no resources. There's nowhere to go. It's not going to error out because that's not an error. You just don't have any resources. So we need to add some nodes. So one thing we can do is we'll take this declaration. And you can put it in any file you want. So we'll just call this node 1, whatever. We throw it in there. So here's the specification that we want. Now we could say how much memory and CPU this thing has, or we can let CAdvisor do it for us on its next update. So what we're going to do is add one node to the cluster. And I think this will work. It has all my right bits in it. So what you do with Kubernetes now, you can do kubectl create -f, and then we give it that manifest. And it will read that specification and know what type of object it needs to make. This is a node object. We hit enter. It submits it upstream, and it says the object has now been created. So now when we list our nodes, it's unknown because it's just been added to the system. So now the lifecycle of a node takes place. The API server's job now is to go out and verify that the thing is up and running. There's a pattern called health-z where all the endpoints have, all the binaries have, or services have an endpoint called health-z. If I hit it, I should get 200 back, right? And it's your job to do all the complexity and make sure that that works. You can reach Docker, you have file system space, whatever you need to do. It just makes it easy to validate these things. So this will happen for a little while to make sure that this is up. Now, ideally, if you have problems here, someone asked me, like, how do you troubleshoot these things? One thing you can do is you can describe to get more details. If I do describe nodes and I describe this particular node, you get events that happen for this node. So right now there's no events. These are some ugly log messages that I don't need. So right now I know that this thing has not contacted this node at this IP or this host name. So this name needs to be resolvable from the API server. If I jump on the API server, I need to be able to hit this DNS name directly. If I can't, some people don't have working DNS set up. You can use an IP address as a host name override to make sure that the API server can actually hit the node, right? So I could be having trouble here resolving DNS for that machine. Let's try it again from nodes and see if we have a problem. All right, so now it's like not ready. So it moves somewhere into status.